Hello everyone, you are watching a complete video series of UNIX operating system. This is part 12. I am PremnArya. Page fault. A page fault occurs when a program tries to use a page that is not in the main memory due to the demand paging will only load the page into the main memory when it is needed. For example, if the program tries to use page 1 for process A in the main memory, the operating system will interrupt occurs as a result of trying access a missing page because page 1 is not available in the main memory. So how to page fault or why the page fault, because the page particular page is not available in the main memory, so the page will load from a secondary memory to the primary memory. So that is the we call the page fault. And the demand paging, the process of loading the page in the main memory on demand. So whenever page fault occurs, it is known as demand paging. The Unix will perform page swapping only when the program needs certain pages. The page will be loaded in the physical memory from disk only when it is needed to execute. The whole process will not be paged or loaded in the main memory, only the pages needed are swapped in. So this diagram shows the demand paging technique. So how the demand paging perform? So here the program A and program B. So program A use 4, 5, 6, 7 page. So the 4, 5, 6 page will swap out. Means swap out means the all pages swap out from main memory to the disk, and swap in means the page will load from disk to the main memory. So here the uh, process divided into different pages. So the page need suppose 4, 5, 6, 7 page need. So this will page need from disk to the main memory. So here the swap out swap in performed by the swapper. So swapper only swap the particular page. Suppose the 4 page need, the 4 page will swap in from disk to the main memory. And the swapper also called the lazy swapper. Lazy swapper means the swapper only load the particular page from disk to the main memory, not to the all pages. So that is also called the lazy. And here program B need some pages like 17, 18, 19. So this will page will load in the uh, main memory for program B. So this is the swap in. So this is the demand paging, means we demand some page like 17, 18, 19. So the program B demand some pages, the swapper will swap in 3 pages, means 17, 18, 19 in the main memory. So this is the demand paging. Page replacement algorithm in demand paging. So first in first out. So this is the first algorithm. The first in first out, also called the FIFO, page replacement algorithm, removes the page that is in memory for the longest time among all the process currently residing in memory. So the memory management system can use a list to maintain all pages currently in main memory and put the page that arrive the most recently at the end of the list. So when the page fault happens, the first page in the list, which is first comer, is removed, and the new page is the most recently comer, so it is put at the end of the list. So the FIFO algorithm we can understand easily with this diagram. So or with the example. So this is the reference string 0216401031121, and the number of frame is the 4. So this is the 4 frame, or the main memory use the only 4 frame, or this is the 4 size of the frame. So we can load 4 pages, 1, 2, 3, 4. So each frame use or load one page. And suppose this is the main memory, so all reference string we put here in the secondary memory or disk, and this is the primary memory or the main memory. So first start FIFO. So in the FIFO, the first page will find out the uh, in the main memory, but the page is not present. So the page will load from secondary memory. So here the zero load. So this is the page fault because the page is not available in the main memory. So the page load from disk to the main memory. So 0 here put, and this is the page fault. So we also write miss, so we also called the miss. And second is the 2. So 2 find out in the main memory or the in the frame but not present in the main memory. So here is the also page fault and put to the 2. So 0 shift down. So this is the suppose the linked list, and the all uh, frame or page shift down. Suppose in the linked list this is the front and this is the rear. So all page insert from front and remove from rear. Okay. So the next is the 1. So 1 is not available in the memory, so 1 will put here. So this is also page fault. Next is the 6. So 6 not present in the memory, so 6 also um, swap in the memory. So 6 will come. And next is the 4. So 4 is not present. So here only the frame size is the 4. So 4 will swap in the main memory, but the one page or page remove from the from or the frame page from the main memory. So which page will remove? So here in the FIFO, the first in first out. So the first page will come. So the first page will come 0. So 0 will most new come or very first come. So this will remove. So 0 will remove, and 4 will insert. So the 0 remove. So 4 612 shift down, and the 4 will insert on the top. And the next is the 0. So 0 is not present in the main memory. So here is the also page fault. So 0 will shift. So which page remove? So the 2 is the oldest and the very first come. So this second means the second page will remove. So second to remove, and the new page swap in the memory. So 0 will swap. So 461 down in the linked list, and 0 will put on the top. And next is the 1. So 1 is available in the main memory. So here is the hit because the 1 is present in the main memory, so that is the page available. So here is the hit. And the next is the 0. So 0 also present, so here is the also hit. Next is the 3. So 3 is not present, so there is also page fault, and 3 will shift. So which page remove? So here the 1 remove because the 1 come very first. So the 1 will remove, and 3 put. So 0 4 6 down, shift, and 3 will put on the top. And here 1. So 1 also, here is the 1 not present. So here is the also page fault, and remove which one? 6. So 6 will remove, and 1 will shift. And next is the 2. 2 is not also present, so 2 will swap in. So which page remove from the main memory? So 4 will remove because 4 come very first. So it 4 will remove. So the 130 will shift down, and the 2 will put on the top. And next is the 1. So 1 is the available in the main memory. So here is the hit. So in the exam, so the total number of page fault in this example. So the total page fault is the 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 page fault occurs in this example. And how many page hits? The total number of page hits 3 because 1 2 3. So and also come in the exam page fault rate. So how to calculate page fault rate? The total page fault and the total reference string. So reference string is 12. So 9 divided by 12. So 0.75 is the page fault. So this is the FIFO algorithm example. If you have any doubt related to this video, so please write your query in the comment box and also write how was this video. If this video increased your knowledge, so please like this video, share this video with your friends and subscribe the channel and press the bell icon to get the new video notification. Thank you for watching.